begin from the some basic statements and about radioactivity. What is it? Because this natural phenomena is the fundamentals of all nuclear technologies which we can apply. And let me remind you about some main items. For example, we know that everything consists of atoms, and some atoms can be stable. It means that they can live very long time without any changes. But some of elements can have radioactive isotopes. These isotopes can have very great properties like release energy, and this energy can be used for different purposes. Some examples. You can see here the one of the main element in our world is the hydrogen. Hydrogen has 3 isotopes. The first one is a protium. It's not radioactive. Sorry. The second one, hydrogen 2, deuterium. It's also not radioactive. But tritium, which has more neutrons in the nucleus, it has a very great property like radioactivity, and during radioactive decay it will release radiation. This radiation we can divide into some types. For example, alpha, beta, and gamma radiation. All of these types of radiation has different properties. Some of them are very penetrative. Some has a very good ionizing ability. And these properties, of course, we can use in our industry, in our life. So, but first of all, I would like to say that our world consists of different elements and different isotopes, and our air, our water, our earth has, all of them have a lot of radionuclides, natural radionuclides, and we live in such a environment which irradiate us, and we all of us are also as a radioactive sources, because we consist of some radionuclides like carbon 14, potassium 40, tritium, and so on. That's why we live with such an environment for long. That's why we have already adopted to this environment, and it's normal for our life, and we don't need to it's not necessary to be afraid of such a situation, because it's a natural phenomenon. But some radionuclides we need to produce with the special properties, with the particular characteristics. And for these purposes, we use special equipment. And what is this equipment and facilities? Of course, the first one is a research reactor. Research reactor, it's not as a power reactor. It has different properties and different applications. But using such a reactor, we can produce different isotopes with definite properties like half-life, the decay type, and so on. During a special reaction, using special materials, special targets, we generally can produce the necessary items or necessary elements and isotopes, which can be used for medical purposes, for agriculture, for industry, and so on. Also, some equipment like particular accelerators also can be used. They are maybe they have, of course, a different principle of operation, but using special targets, we can irradiate these targets with particles like protons or electrons or maybe neutrons, and we can receive the new materials with new properties, and use also such radionuclides in some areas of its application, their application. So as I said, we can use sometimes as a natural radionuclide, some natural radionuclides for application, and also we can use the new artificial materials which has more favorable properties than natural, and of course all of them are very helpful. Let's talk about some applications of such radionuclides in some areas. Let's start from agriculture. And some techniques which we can use for these purposes. The first one, it's a pre-sowing irradiation. So before planting of different vegetables or crops, we can irradiate such materials with, for example, gamma rays or beta particles. And what we will get after such irradiation? Firstly, we can produce more vegetables or crops, because the capacity, crop capacity, or maybe vegetable capacity will be increased up to 10, 15 or 30%, and it means we will get more yield, more harvest, and we can sell it in different countries, for example. Also, such a pre-sowing irradiation can improve some very important properties. For example, it can increase the content of sugar in, for example, vegetables like potato, like watermelons or other materials, and it will improve its quality, and it will be more tasty. Then radicidation. Radicidation is used for control of pests in our yield. For example, after growing, we collect a lot of crops, maybe dry fruits, we prepare dry fruits, but one of the main problem, it's a loss of such products because of pests. Insects will damage our yield, and sometimes we can lose a lot, lose a lot. For example, according to the common statistic, 5% of all crops we lost because of pests. And using for example, in this case, we can't use traditional methods, for example, like chemicals, because these chemicals will stay in these crops, and we can't prepare any foods after such a treatment. That's why, in this case, we can use just irradiation. Irradiation will penetrate through all of these food products and kill all pests inside. It's very safely for everything, for crops as for us. And then food irradiation. When we have, for example, meat, fish, seafood, or fruits which have a very short shelf life, for example, we can't store fish or meat without treatment. For example, more than 1 day, it will be bad, yeah, after such a stain. That's why we use irradiation. Usually, we firstly pack fish or meat in plastic packages and irradiate directly these products in a special facilities. And after such a irradiation, our food and our fish can be stored safely for months in our refrigerators at the temperature of refrigerators without any changes and without bacteria, fungus, and so on. And it's very important, for example, for countries who export for example, mangoes or bananas or other products, or strawberries, for example, because they have a very short shelf life. That's why they can't, for example, we can't deliver such fruits in different countries. They will be they will be bad. That's why this method is very important, especially for example, spices, which is also can be treated by chemicals. And is it safe or not? Of course, it's safe because this radiation will penetrate, as you can see, through packages without damaging and kill just all bacteria and viruses, maybe fungus, which will destroy our food products. And there is no chemicals inside, there is no other defects and so on. And for example, on this product, you will see such a green sign, as you can see in the corner. This sign is called as Radura, and all products which were irradiated will have such a sign. That's why in a supermarket, for example, you can find such a sign, and it will be it will taught us that this product is safe and you can use it very safely without any change in tests and so on. And nowadays, such a method of food irradiation is very popular in our world because more than 79 countries nowadays use such a method. And all over the world, we have more than 220 facilities which have already used such a method. And I think that all of you have already tasted such a products. Maybe you just didn't mention it, but or notice it, but you have already. And then let's talk about healthcare. Radionuclides, wide usage of healthcare because of diagnostics, because of treatment of very dangerous diseases. And of course, one of the main applications is diagnostic. Diagnostic is a method which will show us where and what is the disease, and it's one of the best way for treatment, for next treatment. And you maybe have already heard about X-ray radiography, because it's a commonly used method all over the world. It was used firstly in 1895 by Röntgen, who discovered such rays. And nowadays it's the common way how to detect, how to image our lungs, for example, our bones, and so on. But during this method, we will get just one single radiological image. But we have improvement of such a method, and very popular right now during the COVID pandemic, it's a computer tomography, which can easily detect, for example, the damages of lungs, but it will be not as an image, it will be as a 3D presentation of lungs. So because it's multiply scans, approximately 60 layers of lungs will be demonstrated and will be collected as one 3D image. And of course, I would like to mention that for this invention, one, maybe not one, scientist got a Nobel Prize. It's very important methods right now in all countries for detecting diseases. Also, some maybe unusual for you method, but this method are very useful for also diagnostics. It's a radiopharmaceuticals, the application of radiopharmaceuticals and positron emission tomography. Radiopharmaceuticals, it's a special chemicals. I have mentioned about them earlier. We produce such a pharmaceuticals using reactors or accelerators, and then we inject radiopharmaceuticals into human body, and these pharmaceuticals will be distributed. Maybe sometimes in different place will be accumulated, and because of their accumulation and because of their properties, they will release energy as a particles or as a gamma rays. We can detect their accumulation, we can detect the processes in the organs, their distribution, and so on, and we can detect defects or diseases using such a method. Also, one of the modern methods, a very precise method for example, cancer cells detection. It's a PET scanning. PET scanning uses very short-lived radionuclides. And these short-lived radionuclides, they are positron emitters. And inside the human body, these positrons will react with electrons, and they will produce two gamma rays, and these gamma rays will be detected, and we will get the image, 3D image, as you can see on this slide. And we can see that there are some problems in maybe in the stomach of this person, because we have here the accumulation of these radionuclides, and these radionuclides were accumulated just in cancer cells because of special processes. So that's why we can image this location of these cancers. Also, about treatment, nuclear medicine has some methods for treatment of cancer, because our first purpose was to detect cancer. Why cancer is important? Because it has the second place as a diseases causes of the death all over the world. That's why a lot of people die from cancer. And radiopharmaceuticals, in this case, and the treatment can kill cancer cells very effectively. And for example, you can see thyroid gland. Thyroid, as we know, absorbs a lot of iodine, common iodine. But if we will inject radioactive iodine, it will be also absorbed in thyroid gland. And during the radioactive decay, beta particles will irradiate cancer, and our patient will be safe. All cancer cells will be killed, and it will be a good result for such a treatment. Some modern methods like brachytherapy. Brachytherapy, it's a injection or putting the small seeds or small balls of radionuclides capsules inside the tumor directly. And sometimes later, this tumor also will be destroyed because of radiation and radioactivity. For example, prostate cancer nowadays is treated by such a method, and it's a very popular method. Then gamma knife. There is no invasion. We just have such equipment. This equipment inside has approximately 200 sources, radioactive sources, and of cobalt-60. And these sources of gamma radiation will be collected in a just special zone in the brain where the tumor is located, and the tumor will be burned by gamma rays. And that's why patient just after such a procedure will stand up and go home without any damages, and some days later the cancer cells will be destroyed and a patient will be safe and treated. So that's why we have a lot of opportunities to treat cancer, sometimes other diseases, from using such tools. Except for like treatment and diagnostic, we can use in other way ionizing radiation for sterilization, for example, because we need to produce very clean items as a clothes for surgeries, as a equipment and tools which we use commonly in hospitals. And we don't use chemicals in this case. We don't contaminate our environment. We just irradiate such items, and all bacteria and fungus will be killed. So it has a high reliability, it has a high performance, and it's very commonly used. For example, in Russia, we have approximately 10 such centers of sterilization of medical products. One of the main application of ionizing radiation for fighting with insects. Such insects can kill a lot of people because of such epidemics of viruses, or usually viruses. And we can kill such flies like tsetse fly or mosquitoes or screwworm fly using our methods. We capture, for example, or reproduce population of insects. Then we irradiate just males in this population, and we release such a irradiated population in the environment, and they can't produce offsprings, babies, because these males are suffered from irradiation. That's why we have a increasingly stopped the production of these flies in the environment. So we can kill using such ethic methods for these pests. And there are a lot of course, applications as desalination of water, because the lack of fresh water is very acute question in the modern world. But using, for example, seawater and using such technologies, we can produce a lot of dissolved water. We can preserve food. We can use such tools in industry, like smoke detectors, like also defectoscopes and so on, and some other effects, some other applications, for example, which you have seen everywhere, because we have a lot of threats from terrorists, and using such as scanners, baggage scanners or full body scanners, we can detect the special items which can damage people. Then we can use it in for restoration of great creatures of our architectures and so on. We can, for example, use X-ray fluorescence spectroscopy to determine the chemical composition. And David of Michelangelo, he lost his nose, and it was quite important to determine the content of this material to restore his nose. And you can't see that there is no difference between the previous version and the nowadays version. Also, we can conserve such items like mummies and also very old papers, which are very important for saving. You can see the application of desalination of seawater. It's one of great example. Aktau, Kazakhstan. This city didn't have any water supplies. That's why only water from power reactor and this treatment was used for their purposes as for drinking water.